Hi psychology class, welcome to your third and final video on Unit 3A. So this is cognitive factors in learning, our third theory of learning. And so cognitive is just a fancy word for thinking. The cognitive theory of learning is going to believe that we can learn stuff just by thinking about it or by watching others. And so the key to this theory is that unlike the other two that we've already discussed, cognitive theories of learning are going to say that learning has purpose or has meaning, and that it's not as mechanical as our two forms of associative learning that we did previously. Remember, video 1 was on classical conditioning and video 2 was on operant conditioning. And so before we start with our final theory of learning, let's talk about why it exists, or in other words, what the limits are to those other two theories of learning you've already learned. And so let's start with the first one, Pavlov and his dogs and our unconditioned stimulus being paired with a neutral stimulus to give us our conditioned response. The problem with this is that classical conditioning doesn't really fit well in that with all forms of learning, and that this idea that any stimulus can serve equally well as a conditioned stimulus goes against our biological makeup. And so if you remember some of the examples we did on our practice worksheet and our examples in class, classical conditioning seems to work really well when the association is occurring between things that we come biologically prepared to learn. And so remember our examples of taste aversion, right? The whole, I happened to have the flu once, and the flu coincided with me eating mass amounts of Fritos. Yeah, so the reason I learned to have a taste aversion to Fritos was because it's being paired with something that I naturally hate, getting the flu. If I were living out in the wild, that would serve me well. And that if I were to eat some sort of plant or berries, that made me wicked sick, I wouldn't eat them again. Perhaps they are poisonous or harmful to me. And so classical conditioning works really well only on those things that are related to our biology, like sickness, pain, temperature. Think of all those examples on our worksheet. Most of them involve a conditioned stimulus that is related to biology. Same thing with operant conditioning, is that we easily learn and retain behaviors that reflect biological predispositions, right? We tend to learn associations that are naturally adaptive. And so think about some of the examples that we talked about in class concerning animal training, right? If you remember the different types of reinforcers we learned about, the first type of reinforcer we did was a primary reinforcer. And remember that that was a reinforcer that we don't have to teach someone to value, that they just naturally value it. And so that's why in animal training, the majority of the things we start out with are treats or food, and that you don't have to teach an animal to desire that. And then you can begin pairing all sorts of different things with that primary reinforcer. And so, again, showing some limitations. All right, so what do the classical conditioning theorists say about cognition or thoughts? They don't like them, right? The majority of people that subscribed to classical conditioning theories were from a subfield of psychology known as behaviorism. And that's just saying that psychology should be an objective science based only on observable behavior. And see, so a lot of those psychologists didn't like this concept of cognition because they're, we can't, scientifically measure people's thinking because it's not something that we can see or observe. But the problem with this, right, the criticism of that, is that there's no room for considerations of thoughts, perceptions, and expectations. And clearly those play a role in that, this would explain why, as a teacher, you can, see different types of learning occurring every day. And it's not nearly as mechanical as these theorists, claimed it to be. What did the operant conditioning theorists say about thinking? Okay. They, again, were kind of under the thought that you needed a reward to learn anything, or you needed a punisher to stop doing things. Negative reinforcement could work, but the key was that the only way learning happened to an operant conditioning theorist was if there was some sort of external force acting upon you. And so the problem with that is that we know that there are examples in our lives where learning has happened without reinforcement. And so we'll do examples when you come to class, but know that, a lot of learning happens because of intrinsic motivation. Intrinsic just means inside versus extrinsic motivation. That would be an outside force acting on you. And so intrinsic motivation is the desire to do a behavior for its own sake. And so, are you watching this video because you want an A in psychology class? Well, that's an extrinsic motivation. Are you watching this video because you just know that psychology is awesome and super fun to study and it will make you a more enriched and wonderful person? If you're doing it because you think it's fun or you're doing it just for the sake of doing it, well then you, my friend, are intrinsically motivated. All right, and so our first example of the cognitive theory of learning is right here. It's a direct opposition to operant conditioning. It's called latent learning, and it's saying that learning can remain hidden until it's needed. And so there was a scientist by the name of E.C. Tolman that did an experiment with rats. And what he did is he had two identical mazes and two rats, both of which had never seen the maze before. And he did a number of trials where rat A would be put in a maze that contained little food pellets at every correct turn. And so Tolman was using operant conditioning. He was using a primary positive reinforcer of food to condition the rat to run the maze correctly. And so he would do a number of trials where the rat would get to practice running the maze and would be reinforced with each correct turn. Rat B, meanwhile, was just left to explore the identical maze at its own free will. And so Tolman's idea here was that obviously, if operant conditioning is true, the rat that had been trained to find the end of the maze is going to find the end of the maze better than the rat that's just kind of him-hawing around in the maze, just dilly-dallying around and exploring on its own. But actually what he found out is if you put both rats in the maze and put food at the end of the maze, that, believe it or not, the rat that was just exploring the maze could find the end just as quickly as the rat that had been trained to. So the significance of that is that we, rats and people alike, as we learn things, make these sort of cognitive maps in our mind or mental representations. And so even if you didn't know you would need that information in your future, it was still somehow stored in your mind. So that second rat that had just explored that maze clearly had learned something, even though most people before latent learning was a theory wouldn't have thought that that was possible. Okay, and our second and final example here of observational learning is that of cognitive theories is observational learning. And so observational learning is the theory that says learning can happen by watching and imitating others. Okay, so think back to being a kid and, reenacting your favorite superhero or your favorite cartoon, reciting lines from your favorite movie. Those would all be examples of observational learning. And so we just call that process modeling, right? We model behaviors that we see in other people. Remember, the reason that this can happen is that we have these super fun neurons in our cerebral cortex known as mirror neurons, and those are neurons that fire while observing or imitating others. If you remember in the brain games video we watched earlier, it was talking about how this is why you can cry when you watch a sad movie, or you can wince in pain when you watch a horror film, or you can actually feel happy when somebody smiles at you. And so the person that was in charge of really solidifying this example of cognitive theory was Albert Bandura. And his famous experiment was known as the Bobo the Clown experiment, right? And it was talking about having children in the experiment actually watch a big blow-up doll, a big blow-up like clown doll, being treated specific ways. And so one of the groups of kids got to see children, or got to watch a video of adults treating the Bobo clown very civilly, right? While the other group of kids got to watch a video of adults punching the Bobo clown doll. And so Bandura would allow, the kids free playtime after watching these videos, and then would begin to observe, what children would do as a result. And sure enough, if children were left in a room with the same Bobo doll that they'd seen in the video, you would see that they would begin to treat the doll in the same way that they had seen adults treating that doll in the video. And so this really is an famous experiment that is always cited whenever anyone is talking about violence in the media or violence in movies or negative lyrics in music. That will say clearly that children are impressionable and will model behavior that they see adults doing. And so that's why we have ratings on things like video games and movies. And so I think that those two examples, latent learning and observational learning, hopefully show you that learning isn't as mechanical as our classical and operant conditioning theorists claimed it to be, and that lots of times there are things that we learn, frankly, just by watching or imitating, or we learn just because we didn't even realize we needed that information until a future date. And so thank you so much for listening, and bring any questions you have about this theory to class with you the next time we're together.